All right, in this video, we're going to introduce trig functions of any angle. This is a very important section in trigonometry. You're going to see a lot of the ideas from this section applied in future sections throughout. So from right triangle trigonometry, we had angles in standard position where we had our adjacent side on the positive x-axis. Our hypotenuse is always opposite the right angle. It's the longest of the three sides. And then our angle in standard position, we have a side opposite that angle. Well, in the coordinate plane, the opposite side becomes a y coordinate, the adjacent side becomes an x coordinate, and the hypotenuse becomes r for radius. And the reason for that is because we can actually spin this radius around and have our hypotenuse end up anywhere in the coordinate plane as we rotate around and around and around. So the key difference is, again, in the coordinate plane, the adjacent becomes an x coordinate, the opposite becomes a y coordinate, and the hypotenuse becomes a radius of the circle that we can rotate around the coordinate plane where the center is the origin, and wherever we end up, we'll have an x coordinate to it and a y coordinate to it. So for instance, if our radius, like a spinner, ended up in the second quadrant, our x's are negative and our y's are positive. So the biggest difference between this section and the one on right triangle trigonometry is, in this section, our trig ratios can be positive, negative, or zero, or even undefined, depending on the value of the x and the y coordinates. So depending on what quadrant you're in, or even if you fall on an axis, your x and or y coordinate could be positive, negative, or zero, which means your trig ratios could be positive, negative, zero, or undefined if you try to divide by zero. And we'll see examples of undefined trig ratios in this section. So we're going to calculate the 6 trig ratios for a point in the coordinate plane. So any one of these points on this circle will have an x and a y coordinate to it. And we're going to start by finding the value of r there. So in the coordinate plane, our 6 trig ratios, we had the sine was the opposite over the hypotenuse, the cosine was the adjacent over the hypotenuse, and the tangent was the opposite over the adjacent. Well, in the coordinate plane, the opposite is the y coordinate, the adjacent is the x coordinate, and the hypotenuse is the radius, or the value of r. So the opposite over hypotenuse for sine in the coordinate plane now becomes the y coordinate divided by the radius, or the value of r. Cosine was adjacent over hypotenuse, and in the coordinate plane, the adjacent side is x, the hypotenuse is r, so cosine is x over r. And the tangent was opposite over adjacent, which becomes y coordinate over x coordinate. And then we also looked at the reciprocals of each. So the reciprocal of sine is cosecant, so that's going to be the radius r divided by the y coordinate. The reciprocal of cosine is secant, and that's going to be r over x, the radius divided by the x coordinate. And cotangent is going to be the reciprocal of tangent, x over y, or the x coordinate over the y coordinate. And so, especially with the tangent, cotangent, secant, and cosecant, where x and y can be positive, negative, or zero, for some of these we'll get zeros, like we'll see for sine and cosine as well, but for others we'll also get undefined. The value of r is always going to be positive because it does represent a radius, it does represent a distance, and distance is always positive. So for a given point, find the exact values of the 6 trig ratios, or trig functions, for the angle drawn in standard form. Now, I'm going to use trig functions and trig ratios interchangeably. They mean the exact same thing. So first up, we're going to find the value of r. We have our x is 3, our y is negative 4. So using Pythagorean theorem, just like with finding the hypotenuse, x squared plus y squared is going to equal r squared. So we have 3 squared plus 4 squared equals r squared. And again, I'm going to remind you to ignore the negative signs with your coordinates so that way you don't get the wrong answer from typing it in wrong and forgetting to put the negative numbers in parentheses and then the squared exponent outside the parentheses. So if you just ignore the negative number, you should be okay. So 3 squared plus 4 squared is r squared. We get r squared is 25. So when we square root 25, we get 5. So our sign is going to be y over r, which is negative 4 over 5. So notice now we can have negative values for our trig functions, for our trig ratios. Cosine is x over r, so 3 over 5, or 3/5. Tangent is y over x, which is negative 4 over 3. The reciprocals for sine is cosecant, so r over y, 5 over negative 4, or negative 5/4. For cosine is secant, so r over x is 5 over 3, reciprocal of cosine. And the reciprocal of tangent is cotangent, is x over y, 3 over negative 4. Just a friendly reminder, especially in the negative ratios, the negative results here, that you could put your negative sign on top, on the bottom, or out in front. So please bear that in mind. R will always be positive though because it is a distance. So x's and y's could be negative, but r will always be positive. Example 1b, we have negative 8, negative 15, so we're in the third quadrant. So ignoring the negatives, 8 squared plus 15 squared is r squared. So 8 squared and 15 squared is 289. Take the square root of 289 and we get r is 17. So sine is y over r, negative 15 over 17. Cosine is x over r, negative 8 over 17. Tangent is y over x, negative 15 over negative 8, simplifies to 15/8. Now the reciprocals, reciprocal of sine is cosecant, so r over y is 17 over negative 15, or just take the reciprocal of sine. Reciprocal of cosine is secant, so that is going to be 17 over negative 8, r over x. And then reciprocal of tangent is cotangent, which we could use negative 8 over negative 15, simplifies to 8/15, or take the reciprocal of our tangent answer, and we'll get 8/15. All right, our last example for this video, we have negative 1, 5. So here we're in the second quadrant where x is negative and y is positive. 1 squared plus 5 squared is r squared, so r squared is 26, which means r is the square root of 26. And that cannot be simplified any more than it already is. So the sign of a in this point is going to be y, which is 5, over r, which is the square root of 26. And remember, we cannot have square roots or any radicals in denominators. So if we rationalize this, we're going to multiply the numerator and denominator by the square root of 26. And 5 times the square root of 26 is 5 square root of 26. Square root of 26 times the square root of 26 is 26. So rationalizing those denominators just like we did with the radical expressions section. Cosine of angle A is going to be x over r, negative 1 over square root of 26. And once again, we have a square root in the denominator, so if we multiply the numerator and denominator by the square root of 26, that should clear that up. Negative 1 times the square root of 26 is negative square root of 26, and square root of 26 times square root of 26 is 26. So no more square roots in denominators. Tangent, a lot easier for this one because y over x, 5 over negative 1 is negative 5. So no rationalizing of denominators for that one. For cosecant, rather than take the reciprocal of the simplified answer, let's go back to cosecant as r over y. So we have square root of 26 over 5, which is also the reciprocal of what we started with at the beginning of the sign of this angle A in this problem. So r over y is going to be square root of 26 over 5. And notice we don't have any square roots in the denominator to worry about. Reciprocal of cosine is secant, so we can take r over x, or the reciprocal of what we started with. We get 26 divided by negative 1 is, or square root of 26 rather, divided by negative 1 is negative square root of 26. And finally, the cotangent, x over y, is negative 1 over 5, which is the reciprocal of tangent. All right, that about wraps it up for this video. Thank you very much for watching, and I'll see you next time.